Before we answer this next example, we have to learn about a whole new kind of function that you've never, ever, ever seen before. So watch this. What if I had a function, g of x? I'm going to use that same function that is in your example. G of x, and it's defined to be the area under the curve, f of t. So the area under this curve, between 1 and x. So starting at 1 and going up to x. So imagine if I if I wanted to find g of 3, I would find 3 here, and I'd do whatever I had to do to find the area under this curve between 1 and 3. That would be the value of g of 3. G of 5 would be the area under the curve starting at 1 and going all the way up to 5. So we're going to use a function like that for our next example. So here we go. I have g of x as the integral from 1 to x of f of t dt. That means find the area under f between 1 and x. And we've been given a graph. This here is f of t, we're told. And we can see where 1 is. So if I want to compute g of 1, think about what the function notation g of x means. It means later if I ask you to find g of 1, you're going to take that 1 and plug it in everywhere you see x. So one important idea here, we don't want you to get confused about it. It's a common misconception here. When I find g of 1 is going to equal the integral from 1 to 1 because I'm replacing the x with 1 of f of t dt. Notice I haven't plugged in the 1 for t because g is a function of x, so when I have a number in the little sort of input bucket for the g function, I'm only going to replace the x's with that. Now this says find the area under the f curve between 1 and 1. We'll go back to that rule that we learned a second ago, is that if your lower limit and your upper limit match, then the value of the integral must be 0, because we've been asked to find the area under a curve between 1 and 1. Well, that's a distance across of 0 to fit infinitely many rectangles into. Each rectangle is going to have a width of 0. So g of 1 is equal to 0. I'm going to come up here. To find g of 4, for letter B, I'm going to take my g function and replace the x with a 4. That's going to be the integral from 1 to 4 of f of t dt. We have to go back to our understanding of what a definite integral is. This means find the area under the f curve between 1 and 4. So here, between 1 and 2, it looks like I have a trapezoid. I'm going to add the area of that little triangle, and I'm going to subtract away the area of that triangle that hangs under the x-axis. So I'm going to add together I'm going to combine together 3 areas. The area of the trapezoid that falls between x's 1 and x's 2, the area of the little triangle which falls between x's 2 and x's 3, and I'm going to subtract away the area of the triangle that hangs below the x-axis that covers the distance between x's 3 and x's 4. Now that's not a calculus idea. That's a geometry idea. The calculus says find that area. It's my job to remember everything I learned in geometry and decide how I want to split it up, remembering that to find the area of a sort of an odd shape, I can split it up into separate chunks. So I'll find those 3 areas. That first shape is a trapezoid, so I'm going to average the parallel sides. I can't quite read these numbers, I have to look them up online. Alright, so the area under f between 1 and 4 is going to be the area of the trapezoid plus the area of the triangle minus the area of the triangle that hangs down below. So that trapezoid has parallel sides that have a height of 3 and 1. So I'm going to average the parallel sides and multiply by the distance in the other direction, so that has a width of 1. I'm going to add the area of the triangle, 1/2 base times height, 1/2. The base is 1. The height is also 1. And I'm going to subtract away that little triangle that hangs below the x-axis, which happens to also have an area of 1/2 times base times height, which is 1/2 times 1 times 1. So here I have 4/2 is 2 plus 1 minus, whoops, 2 plus 1/2 minus 1/2, which makes a final answer of 2. To find g of -2, I'm going to start by replacing x in the g of x rule with a -2. That gives me the integral from 1 to -2 of f of t dt. Now remember, we integrate from left to right, so these limits are out of order. So my plan here is to change the order of the limits, but that means I'm going to have to bring a negative sign out to the front of my integral. So g of -2 is going to equal the opposite of the integral from -2 to 1 of f of t dt. It's a dt. So now I'm going to look at the picture, and for me it looks like between -2 and 1, the area I'm interested in is this triangle, which is clearly above the x-axis. So this is the negative sign that was already there, and I'm going to write the formula for the area of a triangle. It's going to be 1/2 times base. The base of that triangle covers the x values from -2 to 1, so that's a distance of 3. And the height of that triangle is also 3. So 1/2 times 3 times 3 makes 9/2. My final answer here is going to be -9/2. One more example down here. We're going to combine together now some of these rules that we know for evaluating definite integrals. We've been told that the area under the f curve between a and b is equal to a plus 2b. That's been given. We've been asked to simplify this expression, the integral from a to b of f of x plus 5 dx. So I'm going to apply the sum and difference rule for definite integrals. I'm going to start with this up here. So the integral from a to b of f of x plus 5 dx is going to equal, I'm asked to find the area under a function given by a sum. So I can break that up into the sum of two separate integrals. This is going to be the integral from a to b of f of x dx plus the integral from a to b of 5 dx. So my next step is to notice that I already know the value of this integral. It was given, so that's a plus 2b. And then I'm going to add together the value of this integral. So the area under the curve 5, the area under the curve y equals 5 from a to b. So remember, the area under a constant, the definite integral of a constant, I'm just going to compute, that's the height of my rectangle, times the distance across my rectangle is the difference between these limits b minus a. That was from your last paper, right? So this is a final answer. It'd be totally appropriate if you were in a free response section. This is a multiple choice question, so I'm going to simplify and combine like terms. That makes a plus 2b plus 5a minus plus 5b minus 5a, which makes minus 4a plus 7b, so 7b minus 4a.